So 95 says a distance, from city A to city B, a plane flies 650 miles at a bearing of 48 degrees. From city B to city C, the plane flies 810 miles at a bearing of 115 degrees. Find the distance from city A to city C and the bearing from city A to city C. Alright, so you're going to start at city A. And because it didn't tell us the bearing direction, it's always north going towards the east. So we're going north towards the east at a bearing of 48 degrees. So that means this little angle right here is 48. And that's going to get us a city B.
48 from the x-axis.
Alright, then it says from city B to city C, the plane flies 810 miles at a bearing of 115 degrees. So we're going to go 115 degrees north towards the east for 810 miles. So here's the thing. Is that 810 miles?
No.
Or is that 810 miles?
That is.
Actually, no. The first one's going to be. And it's because of the angle that it's at. But we don't know that at this time. And so, like, there's times when I draw it, I'll draw it wrong. I'll end up with my angle. I'll end up with one of my sides that is shorter will have a longer measurement. And that just tells me that I need to redraw at that point, but all my pieces will be the same. Alright, so that means that this angle up here is 115 degrees. Whoops, that's a big degree mark. And it tells me I'm looking from the distance from city A to city C. So I'm looking for this. And I want the bearing from city A to city C. Now it's hard to see with the drawing that I have there, but it's still going to be north going towards the east there, okay?
So can't you do 90 minus 48 to find
Alright, so we're after that angle, theta, and we're after that distance, d. Now I got to figure out how to find that. What can we do? Well, let's draw in some stuff. Well, first, let's see. I know this little angle right here, don't I?
65.
How'd you get that?
180 minus 115.
180 minus the 115. Okay, I also know this little angle right here. What is that? 48 degrees. How do you know that? Alternate interior angles with the 48 degrees that they gave us. Good. Alright. What if I do this? What if I...
No.
Yeah?
Why can't you just draw a line right down the middle?
Because if I draw... Okay, good question. I'm going to erase it after I do this. So why can't you just draw a line down the middle?
It makes both lines.
They're not 90s.
They look pretty 90s.
But they're not.
Well, they could be 90s if you...
They're not. But I just forced that one up there to be a 90.
Oh, also...
So what is this little angle right there?
9.
That's got
45.
whichever angle would 8.
42, yeah.
42. Because the other one was 48 degrees inside there. And I can find their sides, can't I? So I could find, we'll call this side A.
If you really wanted to.
I don't know if we need it or not, but I don't know what else to do to get there. So you know what? We're going to try it.
There's another thing we could, you could,
Okay.
like, is that technically 90 right there? Is that bottom left corner right there?
Those three angles together are where it has the 48 degrees, this angle there, and that little angle there.
Oh.
Are 90, okay?
Oh, we should draw a triangle up on the bottom.
We will in a few minutes. Let's deal with this one. Alright, so if I want side A, I can use either the 42 degrees. Oh, you know what I didn't do? I didn't label my sides.
Yes.
Oh, no.
When I was writing out my measurements, it said that first path it went for what? 600 and, say it again? 650. So this side is 650. And this one's 810.
Now we can do.
That confused me. Now I understand.
Oh, I'm sure. Alright, so now I know an angle and a side of a right triangle, so I can find side A. I can say sine of that 42 degrees in the upper right corner of it is equal to side A over the hypotenuse of 650.
Yes. Which is 650 times 7.
So it's 650 times sine of 42 degrees.
We know Tom's like right. He's the calculator.
All right, so we got for side A 434.935. The small top side over here on the left, I can label that B and we can find it. I'm going to use the 48 degrees in that triangle. So I know sine of 48 degrees equals opposite, which is side B, over hypotenuse, which is 650. Not degrees. All right, so then we get B is equal to 650 times sine of 48 degrees. All right.
You broke it.
Oh, way to lick it in there.
All right, so we got 483.044.
Yes.
All right. Well, what if I go on across here and make another right triangle?
Oh, wow. Oh, no. It's starting to get harder and harder.
All right, well, what is this? I'm going to change colors here. I'm going to do a light blue. What is that angle right there?
42.
No.
Nope, it's not. That would be
It is
65
35.
minus 90. 90 minus 25.
25, which means this angle right here is,
Oh, because this is.
Where did you
Oh,
get
and the
65?
one next to that.
because the 65 and some angle have to equal 90 right there.
Yep, so that would mean the box equals 90.
Good job.
And the one next to it is 25.
No, not at the bottom.
That's not how it works.
That's not a right angle when you put the two of them together. All right, but let's go ahead and let's find our side. So this is going to be side C. And I'm going to use the 65 degrees to find it. So I know that sine of 65 degrees equals C over the hypotenuse, which is 810. So 810 sine of 65 degrees. All right, so we found C was 734.109. I'm gonna label this side E, since side D is the one I'm looking for. I'm gonna use that 25 degrees. So sine of 25 degrees is equal to side E over 810. Yeah, because that's all right. So we found side E was 342.321. Well, now what if I come down here and I draw a little rectangle here? Now be careful, because remember we're after D. And let me go back here so I can erase D for a second. I'm going to put D inside instead of there at the bottom. So I'm still after side D there. So if I do that, now that's going to be a little right angle.
Real small.
I can find this side here, let's call it F. How can I find side F?
It's the top.
It's the top two added together. So side F is equal to side B plus C. So it's what, 483.044 plus 734.109. So we added sides B and C and we got 1217.153.
That's not close to what I got.
Well, I can also find side G over here on the right. How?
Subtract.
Subtract. Take A minus side E.
Okay, how does that,
So A
Stop.
All right, so we got 140.723.
Can you just find 3?
Point 723.
Can
Can't you now just find the other angle because the right triangle by Pythagoras,
So I can find side D by using Pythagorean theorem?
Yep.
Yes. Alright, so we know that A squared plus B squared equals C squared, right?
92.6.
So in our case, it'd be what, F squared plus G squared?
Well, I don't think that's right. I got 92.6.
Alright, we gotta go back. There's a mistake here.
No, I actually did.
So 434.935 minus 342.321. I had the wrong number typed in, I'm sorry. It says 92.614. Is that better? Alright.
Well, Michael.
Alright, but same idea now. To find, excuse me, to find side D, we're going to take F squared plus G squared equals D squared. So it's at 1217.153 squared plus 92.614 squared to get D squared. And then we're going to take the square root of that to get D, aren't we? Alright, so let's do that. Alright, so we typed this in and we got 1,220.671. What's my units?
Miles.
Miles. Good. Alright, so that's one of the things it asks for. And the other one is I need to find theta.
Oh my god.
This is the.
What about?
So wouldn't that just be 1.2 kilomiles? What?
Anyways. Alright, so
Can you just find that angle that's by city A by using opposite and adjacent?
okay. Yeah, guys, we can find this little angle. Whoops. Yeah, where I put the big blue mark there. I can find that little angle there. Let's call this angle K. Let's find that, and then we know that these three angles together make 90 degrees, don't we?
Yeah.
So once we find it, we can subtract the 48, find that angle from 90, and that'll tell us what our angle. Well, I'm sorry. Actually, we don't have to subtract the 48. Just subtract it from 90, and that'll tell us what theta is. Because that's what we're after. All right.
Subtract it from 90 though.
So how do we find K?
All right. So how do we find K? Well, I know from that K and that right triangle that it's in, I know opposite and I know adjacent, right? I also know hypotenuse. I just didn't write it up there. So what trig function do you want to use?
Opposite over adjacent.
All right. So tangent. So tangent of angle K equals opposite. So 92.614 over adjacent. 1217.153. How do you find K?
-1.
Good. The inverse tangent of what we just put there in that fraction. All right, so let's do that.
It's not too late.
All right, so we found that K is 4.351 degrees. But remember, this 48 degrees, my unknown angle right there, and K make 90 degrees. I need those top two angles to get my theta. So all I have to do to find theta
90 minus 40.
is we're going to take 90 minus K. So my theta is going to be 90 degrees minus 351? And so we got, what's that, 85.649 degrees? Now let's go ahead and write it in terms of bearings like we're supposed to. So which direction is that angle coming from, north or south? It's coming from the north. It's going towards the east. And you said it's 85.649 degrees. And so there's my bearing. And we already have boxed over there in blue our distance from city A to city C.
Oh my gosh.
Wow.